Hi everyone! In this video, we'll take a look at how to sketch the graphs of polynomial functions when we are given the equations in factored form. I'm going to take a look at a couple of questions to give you an idea of how to complete your homework. And for this, I am choosing equation C and equation F. So one is third, the other fourth, and I will do equation D as well. So here we have the factored form of a polynomial function. As you can see here, we have 1, 2, and then 3 factors. Based on the factors, we'll derive the x-intercepts. So for x minus 2, we'll have the x-intercept at positive 2. X plus 1, the x-intercept must be at negative 1. And x plus 3 will have the x-intercept at negative 3. So once you plot the x-intercepts, you're going to need to know what the y-intercept is. And this is easily done by setting x equal to 0. And that will give you f of 0, which is the y-intercept, equal to negative. And then 0 minus 2 is negative 2. 0 plus 1 is 1. And 0 plus 3 is 3. So that will give the y-intercept at positive 6. So I'm going to set the scale in here by 2. So 6, 8, 10. And I think we're ready to sketch the graph now. So here is the y-intercept. Now, you have to check and see what the degree of the polynomial function is and identify whether it is even or odd. So this is 3 factors to the power of 1, which makes this degree 3. So you add the powers of each factor. And the leading coefficient is negative. So this is an odd degree function with a negative leader. And that means that this function will behave like the simplest odd degree function, which is linear functions, with a negative leading coefficient, which means with negative slope. So this tells us that this graph is going to start in quadrant 2 and end up down here in quadrant 4, because it has to follow the end behaviors of a line. Now we're going to get started in quadrant 2 and we'll walk towards the x-intercept. So the intercept on the left end is negative 3 here. So the first x-intercept, so we're going to hit that x-intercept. We're going to get through it because it's a first order x-intercept. And obviously we need to go and meet this x-intercept, which means we need to make a turn somewhere. We're going to get through the x-axis because, again, it's a first order route. And we are going to go ahead, go up, and remember that we need to meet the graph right here at x equals 2, which means we need to make a turn. Now, there are various ways to sketch the graph. Remember, we are sketching, we're not graphing with very high accuracy. But when I see here the distance from negative 1 to 2, that's a distance of 3 units. So somewhere in here must be the turning point, somewhere in the middle, not exactly in the middle. That depends also on the other coefficients here, which means that I can hit the y-intercept before making the turn. So that would be going up. All right. And then I'll make a turn somewhere and then I'll go down this way. And voila, this is the graph of this function, or a sketch, not a graph. And we're going to say degree of the function is 3. X-intercepts are at 2, negative 1, and negative 3. Moving on to the next equation, we're looking at f of x equals x minus 2 squared times x plus 2 squared. So the degree of this function is 4. We find the degree by adding the exponents of each factor. The x-intercepts of this function are at x equals 2. So you solve this one, this factor, x minus, you set the factor equal to 0, and x plus 2 equals 0, that's x equals negative 2. So when x equals 2, that means we have an x-intercept at 2, an x-intercept at negative 2. Now, with a degree 4, which is an even degree, and a leading coefficient that is positive, so we have the coefficients 1, 1 squared, 1 squared, So that's a positive leading coefficient. We're going to say that even degree function that behaves like a parabola with positive leading coefficient will be a graph that starts in quadrant 2 and then it's going to do whatever in here and then go up to quadrant 1 again. So the y values must point towards the same direction at the ends of the graph because even degree function, right? Okay, so the x-intercepts, as we mentioned, are at 2 at negative 2. And x equals negative 2. And we're going to also add that both roots or both x-intercepts are of second order. That's because they come from factors brought to the power of 2. So that's second order. And the other one is also second order. So what that means is that we're starting, remember, in quadrant 2 to quadrant 1, we said, because it's like a parabola that opens up, even degree that has a positive leading coefficient. So we're going to start our journey somewhere here. We're going to aim towards x equals negative 2. Because we know it's an order 2 root, we're going to make a turn exactly at x equals negative 2. Now, another thing we want to do to add accuracy to the graph of the function is find the y-intercept. For the y-intercept, we simply set x equal to 0, and that will give us 0 minus 2 squared times 0 plus 2 squared. So that will make 16. So 4 times 4 is 16, which means that I'm going to go by a scale of 4 units for each increment. And I'm going to say that when I make the turn, I'm going to make sure to hit 16 and then come back again because I need to meet the next root, which is at 2. It's again a double root, so this would be a W-shaped graph. And here are both ends pointing up. Okay? Now, we're moving on to our last example on this group of questions. So this time we have example F. We have one factor x, x minus 2, x plus 1, x plus 3. So all factors contain x, which means that the power of this function will be 1, 1, 1, 1, a power of 4. So the degree of this function is 4. And what we also need to emphasize is the fact that that is an even degree function. I'm going to take a look at the leading coefficient because I know that helps a lot in predicting the end behaviors. And you see that the coefficients of x in every factor are 1, which makes the leading coefficient equal to 1. So the leading coefficient is 1, which means it's a positive leading coefficient. So even degree function with positive leading coefficient will behave like a parabola with positive leading coefficient, so it opens up. And that tells us that the function was starting in quadrant 2 and end in quadrant 1. Next, we have to list the zeros. Remember, we have a factor of x that can give a 0 at x equals 0. A factor of x minus 2, so that will give an x-intercept at 2. Next, x-intercept at negative 1 and another one at negative 3. And since we're at it, we're going to plant the zeros on the x-axis. So we have 2 here, we have negative 1, and then we have negative 3. So it is very helpful to find the y-intercept as well. And again, for the y-intercept, we set x equal to 0. And as you can see in here, we'll have 0 multiplied by 0 minus 2. That means we are multiplying by negative 2. And we're multiplying by 0 plus 1, so that's a 1. We're multiplying by 0 plus 3, which is a 3, so that's 0. And it is also easy to see that based on the fact that the x-intercept is at 0, and that's exactly where the y-axis is passing through, which makes the x and the y-intercept location the same point. So I think we're now ready to draw the graph of this function. And I'm going to get started with sketching. Keep in mind, we need to check the order of each root. They're all orders of 1, which means that at every single root, the graph will just cut through the x-axis. So here I go down, I go up, I go down, and I go up again. Now, if you're wondering how do I know how far down to go here or how far up to go in here, this is something that we are going to learn in the upcoming lesson. So for now, we're just sketching the graphs and practicing what we have learned about the end behaviors and the types of roots of a polynomial function. I actually just spotted another very interesting function, and I'm just going to go over this very quickly. So here we go. The function I is f of x equals negative x minus 2 times x plus 3 to the power 3. So we have a power 1 here, a power of 3 here. That will make the degree of this function equal to 4. So next, we're going to take a look at the leading coefficients. So we have a negative 1 and a positive 1, 1 to the power 3. That makes a equal to negative 1. That's negative. So we have a 4th degree function, which means that we have an even degree function. Negative leading coefficient, which means that this will behave like a parabola, which is the simplest even degree function we know. Like a parabola that opens down. So a parabola that opens down would look like this, which means that the ends of the graph will be in quadrants 3 and 4. So I'm going to mark that here. So our graph will be quadrant 3, quadrant 4. Now, next we have to list the roots. So the roots are at x equals 2, here, and at x equals negative 3. And again, we know how to find the roots now. We make each factor equal to 0, and so for x. So I will mark the roots on the Cartesian plane. All right, and I will also find the y-intercept, because why not? Make x equal to 0, which means that we'll have negative 1 multiplied by 0 minus 2 multiplied by 0 plus 3 to the power of 3. So negative 1 times negative 2 is positive 2. 3 to the power 3 is 27. 27 times 2, 54. So we'll have the y-intercept up here at 54. I will pretend that's a 54 all the way up here, actually, even here. So about here. And 1, 2, 3, 4, 5. That's okay. Now I think we're ready to draw the graph, or to sketch the graph of this function. And what we're going to do is start off in quadrant 3. So from quadrant 3, we are aiming towards x-intercept at negative 3. So we are going up in here. Remember the order of the root. So the order of the root is 3. So what I'm going to do is I'm going to take care of that first. So I will make sure that the shape of the graph shows an inflection point at x equals negative 3, which means that the order of the root is 3, right? We're going to go up here. And now I am going to go all the way up. I will hit the y-intercept somewhere in here. Maybe that was a little bit premature. And all the way down to meet the next root. And this is my very good looking graph in here. The idea is there. So this is a 3rd order root, and this is a 1st order root. I hope you find these explanations useful to complete the rest of the homework questions. Please try them all, and I will see you in class soon. Bye for now.